What's going on, Alex Bros? It's Mr. C here, and in this video what I'd like to do is talk about the process of completing the square, which is a method that we can use to solve quadratic equations, as well as do an example involving it. So here we go. Completing the square is kind of a it's kind of a bittersweet method. What makes it sweet is that it can be used to solve any quadratic equation, as it says right here. Um, but the bitter part of it is that it can require quite a bit, some steps. It can be a little bit of a lengthy process, and it oftentimes involves some fractions. But fractions need loving too. But other than that, it's a pretty nifty method for solving quadratic equations. So I hope after this video you feel more comfortable with it, and maybe once in a while decide to use it to solve your quadratic equations. So as I mentioned, this is a method that can be used to solve any quadratic equation. However, the equation must take on the following form beforehand. Alright, so if we're given a quadratic equation, whether it's in standard form or not, we're going to want to do our best to rewrite the equation so that it looks like x squared plus bx equals c. And note here that b and c are just placeholders for what's going to be real numbers. The reason why you want it in this format is so that you can add a special constant to each side, which allows you to factor the left-hand side as a perfect square trinomial. But before illustrating what you need to add to each side, I do want to make a very important note that it's quite easy to get this in, or it's quite easy to get a quadratic equation in this form, but be very careful. You do need this leading coefficient, or the coefficient of x squared, to be a 1. Alright, so that gets missed sometimes, so that's why I want to just kind of mention it before moving on further. Alright, so if we have x squared plus bx equals c, I can write the left-hand side as x squared plus bx, and what I'm going to add to it is a special constant, which I'll go ahead and open up parentheses. I like to call it a magic number, but this number that I'm going to insert in parentheses is exactly half of the coefficient of x. So I'm going to write that as b over 2, and what we have to do next with b over 2 is square it. And because we're adding a new number on the left, in order to keep this equation a true equation, we're also going to have to add this number over to the right-hand side. So it's going to be c plus b over 2 quantity squared. What this allows us to do, once we've simplified b over 2 squared on each side, it allows us to take the expression that's on the left-hand side and write it as a perfect square. Hence the method of completing the square. And the expression that goes inside the set of parentheses is going to be just regular x now plus b over 2. So if we add b over 2 squared to each side, the left-hand side can be rewritten as x plus b over 2 quantity squared, and the right-hand side I'm just going to say is some sort of number or hashtag symbol. Now this actually does not conclude the process. Well, it concludes the completing the square part of the solution, but if you're looking to solve for x, there's a little bit more that you'd have to do from here on out. So I'll just say dot dot dot, and what you do from here on out is you apply the square root method, or I'll say SRM for short, to solve for your values of x. Alright, so I'm going to go ahead and outline that process right now with a specific example. Here it says solve the quadratic equation algebraically, and we're going to give exact answers. So I'll explain what it means by exact answers at the end of the problem, and then I'll show you how to get the approximate answers just in case. So you'll notice that the quadratic equation here is presented in standard form, and as it says above, we want to make sure that we have this in the format x squared plus bx equals c. Really what all that really amounts to is just taking this 14 over to the right hand side, because on the left hand side what's going to be left over is x squared. Notice that there's a coefficient of 1 minus 6x, and on the right hand side is going to be positive 14. So that's in that format, x squared plus bx equals c. Now, what we're going to have to do is focus on the coefficient of x, which is -6. Let's write x squared minus 6x plus, and in parentheses, it's going to go that -6. We're going to have to divide it by 2 and then square it. And remember, this is also what we have to add to the right-hand side. So it's going to be 14 plus -6 over 2 quantity squared. Well, what is -6 over 2 quantity squared exactly? Well, if you think about it, we have to take -6 and divide it by 2, so that gives us -3. But then when we square -3, we get +9. So essentially, in this part of the completing the square process, we are to add 9 to each side of the equation. Of course, on the right-hand side, 14 plus 9 is 23. And on the left-hand side, we're actually going to be able to factor this. Think about factors of +9 that add up to -6. Those factors would be -3 and -3. So you could factor the left-hand side as x minus 3 times x minus 3. And of course, a nicer way of writing that is x minus 3 quantity squared equals 23. Notice that -3 is exactly what -6 over 2 is. Now, remember, we're not finished at this point. We still have to solve for x, but by virtue of completing the square, it kicks us into the square root method arena. So here's what I mean. We're going to focus on getting rid of this power of 2, and the way to get rid of that power of 2 is to take the square root of each side of the equation. So I'm going to take the square root of the left-hand side, and also the square root of the right-hand side. Now, when you take the square root of the right-hand side, be sure to include plus or minus. And inside there is going to be 23. Now on the left, the square root cancels out the power of 2. So we're left with x minus 3 on the left, and on the right-hand side, plus or minus the square root of 23. Last but not least, we're going to kick this -3 over to the right-hand side from the left. We'll put it in front of the plus or minus symbol, and the -3, which was on the left, is now going to become a +3 on the right. And so we have 3 plus or minus the square root of 23. So really important that you include the plus or minus symbol when you're manually square rooting the number on the right-hand side, because for this equation there are going to be 2 solutions by virtue of the plus or minus symbol, and I'll go ahead and flesh those out. One solution for x is 3 plus the square root of 23, and the other solution for x is 3 minus the square root of 23. So that's how you can solve a quadratic equation using the method of completing the square. Now I do want to note that each of these answers would be considered an exact answer, and that's because nothing has been typed into the calculator yet. But what I'd like to do is show you how to get an approximate answer to each of these using the calculator. So the first answer for x was 3 plus the square root of 23, so I'm going to type in 3 plus sign, and then to get the square root symbol, you can hit second and then this x squared key. That brings up the radical symbol on the screen, and I'll type in 23. And to get out of the radical, you can hit the right arrow button and then press enter. So we're looking at an approximate value of, to 2 decimal places, 7.8. And now what we'll do is type in 3 minus the square root, so second and then the x squared key. 23. Arrow over to the right and press enter. And this is looking to be, to 2 decimal places, about negative 1.80. Okay, because we used the graphing calculator to get these values, they would be considered approximate, or I'll say approx for short. And that's where the pain and torture, fun and excitement for this video ends. If you have any questions whatsoever about what was communicated throughout it, feel free to let me know. Otherwise, thank you for watching, and I will catch you guys in the next video.